Greetings, everybody. Um, Somebody sent me a question about this very question that you see here from MyMathLab, and at least at the time I'm making this video, this is question 13 from assignment 2.2. And often, if somebody asks me a question, unless it's a very simple question, I'll try to make a video answer. Okay. So if you're wondering, should you ask a question, maybe that will inspire you to go ahead and ask it, because I think I can give you a fairly detailed answer that could help you out quite a bit. Okay, so what I thought we'd do is just go through this problem like completely as it is through MyMathLab. I'm going to do my work over here on my whiteboard, and I'm going to put in the answers, and just hopefully you'll get the total experience for how this would work if you were doing this by yourself. Okay, and I hope that helps. If it doesn't help, then we can talk again about it. We'll work something out. Okay, so I'm given this equation to solve, and I'm giving the questions in parts. There's going to be parts A, B, and C. Part A says list all the rational zeros possible according to the rational zero theorem. And that, as is sometimes the case in math, makes it sound more complicated than I think it really is. So let me give you my take on this. What it's asking us is to solve this equation, okay? All right, we're going to solve the equation x third plus 3x squared minus 219x minus 221 equals 0, which would be a fairly complex equation to solve just on a whiteboard with no calculator, or just with paper and pencil or something like that. Now, what it's asking me to do in this first part is list what might be a solution, because actually this type of problem, as we do it in our class, takes some trial and error. And if I don't limit the solutions to what might be a solution, then potentially any number is a solution. And if any number can be a solution, I'll never find it by trial and error. How many numbers are there? So this is just asking me to limit down to possibilities. What might be a solution to this problem? Here's how we do that. This thing that they're referring to as the rational zero theorem says the numbers that might be a solution take this form. They could either be positive or negative, and I have this fraction, and the number down here must divide the leading coefficient. So the leading coefficient is the number multiplying this x to the third power. Okay? What number is multiplying the x to the third power? It's a 1. Okay? So that number I put there must be able to divide into 1. Okay? And then the number I put up here must be able to divide into the last term. The last term is 221. Okay, so that's how you construct the list of possible solutions. That's the list of all the numbers that might be solutions. And I'll show you what we'll do with those might be's, or those possible solutions, in part B, okay? But okay, I'm going to follow through with this. Okay, so the possible solutions take the form, notice I wrote plus or minus, and I need to put the number down here as the number that will divide into 1. There's only one number that will evenly divide into 1, and that is 1. So 1 is the only number I need to put down there. Okay? Now up top here, I have to put all the numbers that divide into that last term, which is 221. Now, okay, to do that, I made a little factor tree, and I actually used some trial and error. You might think of it as, well, I'm just going to get my calculator, and I'm going to go through an order until I find a number that divides into 221, and I'm going to make a factor tree and find all the numbers that divide into 221. So I found that 13 was the first number I came on that divided into 221, and 13 times 17 is 221. And that's as far as I can break down the factor tree. So, okay, here are all the numbers that divide into 221. 1 does. Okay, 1 will divide into any other number. 13, 17, but also 221. So on this top part, you're always going to have the 1 and you're going to have the number, but then anything in between that divides. And if you need to make a factor tree, you can make a factor tree. Okay, so the possible solutions, the numbers that might be solutions, are plus or minus, and then you've got to look at this like all combinations of these numbers up here divided by whatever's down here. So let's do plus first. 1 divided by 1, that's 1. 13 divided by 1, 13. 17 divided by 1, 17. 221 divided by 1, 221. Okay, we're done with those. Now to minus. Minus 1 divided by 1, negative 1. Negative 13 divided by 1, negative 13. And negative 17, negative 221. If this happened to be a 2 down there, I would do 1 divided by 2, 13 divided by 2, 17. And it would change what this would look like, but you know, as it is, I have a 1, but I just have to use those numbers and divide all the combinations. Okay. All right. So now let's put that in here, okay? Because that's the objective, is to also put the answer in. So I'm gonna do like 1. Oh, notice it says use commas to separate answers. Sometimes we make typos on MyMathLab. So I'm going to put 1, 13, comma, 17, comma, 221, comma, and then I had the negatives, negative 1, negative 13, negative 17, negative 221. Now I can't forget to put my commas. So I got my commas, and then that was everything that I found to be a possible solution. Okay, so I got that part. Now to part B. It says use synthetic division to test several possible rational zeros in order to identify one actual zero. So what that is saying is that, well, with regards to this equation, any of these numbers on this list might be answers. And you'll have to go through them in a trial and error fashion in order to figure out which one actually is an answer. Now it says use synthetic division to do that, and I'll leave that up to you, but I'll tell you this: you don't have to do it that way. What does it mean for any of these numbers to be a solution to that? What would it mean, like in the most basic sense? Like if 1, see that number there, 1, which might be a solution, was actually a solution, it would mean that if I took 1 and I plugged it into that I would get 0. It would work, okay? So you could go through these and like plug them in one at a time until you found one that worked, okay? So that would count. If you want to follow the instructions which says use synthetic division, then you could do it that way, but I'm just not so sure that's the fastest way. So I'm gonna pause the video, and I'm actually gonna take these numbers one at a time, and I'm gonna plug them in there until I find the one that works, and then I'm gonna tell you what I found and make some comments about it. All right, so here's the results of my trial and error. So first, I used my handheld calculator, and I just went through these numbers on the list, and it might seem like that would take a long time to do, but it didn't take me that long to figure out that -1 is the number that worked, okay? So, you know, I actually tried, 13 and 17, and I tried 1, and, you're going to have to take my word for it, but it didn't take me that long just punching it in to figure out that of all the numbers on that list that might be solutions, it's the -1 that actually worked. Here's what it would look like when I plugged it into my calculator. I used the parentheses like that and so on, and it gave me 0, and then that means that it worked. It was a solution. Now, I did tell you that it says use synthetic division to figure out which one of these might be solutions is an actual solution. Here's what that looks like. I set up the synthetic division. -1, let's say, is the number in question. Okay. And if I wanted to see if that was an actual solution to this equation, I would set up and go through the synthetic division. And if I get that number there to be 0, it proves that -1 is actually a solution. If right there I get some other number besides 0, it means that whatever you put here to try out wasn't a solution. Okay? So if you put 13 right here, you wouldn't get 0, and it means 13 is not actually an answer. All right. So now however you want to do this, we're down to part B being done. We figure out either way, whether by just plugging the number in or actually going through the synthetic division, that -1 is the number that works. So here I can put in -1. I know that works. I tried it and I confirmed it in 2 different ways, and I checked my answer and it's right. Okay, then part C, it says use the 0 from part B, okay, the one we just found, to find all the other answers. Okay, now again, I know that this might make it sound more complicated than it really is, but you know, okay, it's just saying, you know, there happen to be 3 solutions to this equation. Okay, so if my highest power in an equation, a polynomial, is 3, that means I could have upwards of 3 solutions, 3 different solutions. So far I found one of them, and it's asking me, well, given that you know that what one of them is, can you find the other 2? Okay, so I'll show you how to do that. Now, for that last part, we will need to do the synthetic division. So even if you were taking my approach and just plugging the numbers from your maybe list in until you found the one that works, once you found the one that works, you'll need to do the synthetic division, because the other 2 answers come from this. Okay, so we got one answer right here, and the other 2 answers are here. Okay, so what does that mean? Well, when we set up the synthetic division, these numbers are not random. So that 1 came from being the coefficient of x to the 3rd power. That 3 came from the coefficient of x squared. That -219 came from x, and the -221 was just a number. The significance of these numbers down here is they go with x's 1 less in power than what's immediately above them. So this one is x squared, this one is x, and this one is just a number. So what we get in part C, is an equation to solve that gets us the other 2 answers. Okay? Now, we're going to solve this. 1x squared plus 2x minus 221 equals 0. Okay, so that's our new task. Now, luckily, we have a formula for solving this type of equation. This is a quadratic equation. Okay? I have some other videos linked with these lessons about how to just solve quadratic equations. Okay? But let's go through it and talk about some of the details for the setup, and then we'll go about finishing that out to an answer. Now I'm going to pause the video in order to write everything down, but once I've got it written down, then I'll talk about where every number came from. Okay, so now I've got the quadratic formula applied to this. And again, I would like you to watch my separate video on how to use the quadratic formula, but what you do is you take the opposite of this middle number, so that'd be -2 plus or minus, then you square this middle number, so that'd be 2 squared in this case. Then you do -4 times this leading coefficient, which is 1, times this last number, which is -221. And then divided by 2 times this leading coefficient, which is 1. Okay, so I got that on my whiteboard, and then I calculated this inside part here. I did 2 squared minus 4 times 1 times -221, and I got 888. Now the question is this our answer? So let's look at the instructions. When we work on MyMathLab, there will be some guidelines for how to formulate your answer or format your answer and type it in. Here it says type an integer, and an integer is a whole number. An integer is like 1, 2, 3, 4. Well, this is definitely not an integer. It's not a whole number. Or a decimal rounded to 3 decimal places as needed. So, okay, that's what I'm going to need to do. I can take this kind of number and use my calculator to get a decimal, and then I can round it to 3 decimal places. Now, keep in mind there are 2 numbers here. There's -2 plus root 888 over 2. That's one number, one solution. And there's -2 minus root 888 over 2. That's the second one. I have to do those individually, okay? So first I'm going to get my calculator, and I'm going to do -2 minus root 888 divided by 2. And if I do that, here's what I get. All right, so that turns out to be, it says 3 decimal places on MyMathLab. Okay, that's what I'm going to need. I get -15 point, and I got 3 decimal places after that. 8996. Okay, so there I wrote 4 decimal places, but it only wants 3. So when I round this up to 3 decimal places, see how that's a 9, but that's a 6. So because this digit is 5 or bigger, I got to bump that next one up. But what happens when you bump up the 9? What's the next number? 10. And then that causes you to bump this one up to 10. So those are going to be zeros and 1, and then but 0 and 9. So 3 decimal places, it'd be -15, 900. Okay, so there's the first one. Now I'm going to do the minus. I'm going to do -2 minus root 888 divided by 2. Or sorry, the plus. -2 plus root 888 divided by 2. And I get 13.8996. So same thing with this one. When I round this to 3 decimal places, I'm looking at bumping up this digit based on that one. So the 4th decimal place is a 6. I got to bump the 9 up, which causes me to bump the next 9 up, which causes me to bump this number up to 9, 1 bigger than 8. So, okay, in other words, what I'll get is 13.900. That's 3 decimal places. Okay, so one of these I got from the plus. I got mixed up which one I was finding from which, but you know, this is plus or minus. I do -2 plus root 888 divided by 2. I get one answer. Then I do -2 minus root 888 divided by 2. I get the other. So there are the other answers. Okay. All right. So that's the total procedure. Now I think with a problem this long, it helps to get a bird's eye view of it and just a summary of everything we did. So first, like, this is a hard equation to solve just on paper or whiteboard. So we start by listing all the numbers that might be answers. Okay, and there's a formula for doing that. So those are the numbers that might be answers. Then we use trial and error to figure out which number on this list works. Okay, you can plug into the equation to see if it works. But once you find it, you should also do the synthetic division. The synthetic division, if you get a 0 there, that confirms that the number works. So -1 works either way. There will be 3 answers to this type of equation. You get the other 2 from this, so that would be 1x squared, 2x, and -221 equals 0. But that's the kind of thing we saw by the quadratic formula, which you see here. From there, I've got to follow my instructions on MyMathLab, which says round to 3 decimal places. So I've got to take this weird number here and use my calculator to round to 3 decimal places. Now let's try to put it all in. It says the zeros of the function, which just means that the solutions to that original equation I started with on my whiteboard are, well, let's see. So we've got -1. It might seem unnecessary to list it again, but what it wants here is to list all the answers. -1 is one of them. Then I got -15.900 to 3 decimal places, okay? And then I got 13.900 to 3 decimal places. It says separate by commas. I did that. 3 decimal places, I rounded that way. Okay, always make sure you round correctly. If you're unsure about the rounding, that's something that you can ask me about. We could have a separate discussion. But I got to follow all these instructions here for each part in order to get it right. So I got it all there. That should work. I checked my answer and it's correct. Okay, so I hope that helped to have like a complete walkthrough of the problem. There's still more that we could talk about within the context of solving this problem. You might wonder about the quadratic formula. You might wonder about how I rounded right here. You know, with such a big problem, I didn't go into extreme detail on every single step. But hopefully this will give us something to talk about. And if there was some aspect of what I did here that you didn't understand, then we could address that and it would all come together.